The most voracious black hole consumes matter with the mass of our Sun every day. Discovered in 2018, the black hole, known as J2157, is the most voracious black hole in the known universe. Measurements by scientists indicate that it has a mass about 34 billion times that of our Sun and absorbs material equal to the mass of our star every day. J2157 is one of the largest and fastest growing known black holes in the universe. She also has an appetite befitting her enormous size. According to new research by Christopher Onken and his colleagues at the Australian National University, ANU, this monster is 34 billion times more massive than the Sun and consumes material the mass of our host star every day. The mass of this black hole is about 8,000 times greater than the mass of the black hole at the center of the Milky Way, said Dr. Onken. If the black hole in the Milky Way wanted to grow such a needle, it would have to swallow 2/3 of all the stars in our galaxy, he added. This giant black hole was discovered in 2018 by the same ANU research team. It is located over 12 billion light-years away from us. At the time of its discovery, astronomers estimated its mass at about 20 billion solar masses and its accretion rate, or how much material it absorbs, at half the mass of the Sun per day. Since then, astronomers have conducted new measurements to revise these numbers. At the newly estimated mass, the J2157 black hole would have a Schwarzschild radius, the radius of the event horizon, of about 670 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. Approximately 150 million kilometers. In this context, Pluto in the Solar System orbits on average about 40 astronomical units from the Sun. The heliopause, the place in space where the pressure of the solar wind is unable to repose galactic radiation, is located at a distance of over 100 astronomical units from the Sun. This shows that J2157's event horizon is more than 5 times larger than the entire solar system. We see it at a time when the universe was only 1.2 billion years old. Less than 10% of its current age. This is the largest black hole weighed in the early universe, Onken noted. This means that J2157 could now be much more massive. Scientists don't know why or how black holes could grow to such sizes so early in the universe. Scientists are trying to find more such monsters in the hope that they will provide some clues. But J2157 is not the most massive black hole known to us. An ultramassive black hole with a mass of about 40 billion solar masses lies at the heart of the Home 15A galaxy, about 700 million light-years away. There is also an ultramassive black hole powering the TON 618 quasar. This is an absolute record holder. It has a mass of about 66 billion solar masses. It is located approximately 10.4 billion light-years from Earth. J2157, which existed at a time when the universe was only 10% this century, belongs to its own class of black holes. This discovery poses a huge challenge to our cosmological models, according to which the creation of such an object should take much longer and consume huge amounts of matter. An ultramassive monster lurking in the early universe may be another piece of the puzzle. Beer from a bottle or a can. The answer is not that simple. The dispute over this issue has been dividing people for a long time. Is beer from a bottle or a can better? Which of these containers better helps preserve the properties of the golden drink? The world of science finally became interested in the matter. However, the answer is not that simple. Is it better to buy beer in bottles or cans? The can has the advantage of being easier to distribute and store. However, for beer lovers this matter is of secondary importance. Because the most important thing is the taste. In the journal, ACS Food Science and Technology, scientists published research on this issue, which is important to many. It turns out that the answer is complicated and depends on the type of beer. Transferring the results obtained by scientists to our domestic market may be somewhat complicated due to the selection of beers used in the research, but we should obtain some guidance from them. But let's first think about where the differences in the taste of canned and bottled beer may come from. First of all, beer consists not only of water and alcohol, but also of a huge amount of flavor compounds. These are mainly metabolites of yeast, hops and other beer ingredients. However, what happens when the beer has already been poured into cans or bottles and is stored? Well, as a result of chemical reactions taking place in beer, some of the ingredients disintegrate. But others may then be created. As the beer matures, its taste changes, but it does not necessarily become better. Previous research on this topic has focused only on light lager. Although the goals of these researchers were more ambitious and included amber ale and India Pale Ale, IPA. The aim was also to compare the stability of beer poured into bottles and cans. Appropriate tests have been carried out. Both the amber ale and IPA, in glass bottles and aluminum cans, were refrigerated for about a month, and then kept at room temperature for another 5 months. Every 2 weeks, new cans, bottles were opened to see what the beer stored in them tasted like. At some stage, differences began to be noticed. First of all, they manifested themselves in the context of the content of amino acids and esters in beer. However, this mainly concerned amber ale. In this case, however, it turned out that the beer stays fresh longer when stored in bottles. On the other hand, it turned out that IPA beer is much less susceptible to differences resulting from the way the beer was stored. This is probably related to the higher concentration of polyphenols from hops. On the one hand, they stop oxidation, and on the other hand, they combine with amino acids, causing them to remain in the beer itself rather than settling on the walls of the container in which the beer is stored. The researchers also examined the metabolic profile of both types of beer and found that in both cases it changed over time, regardless of whether the beer was in a bottle or a can. And here it turned out that in the case of amber the difference was much greater. The only thing left for researchers now is to determine how all these changes affect the taste of beer. And once this is researched, beer producers will be able to make much better decisions about which ones to store and under what conditions.